So let's start with the interview problem. By two different threads, you have to print even and odd number. One thread will print, let's say, even thread, which will print 0, 2, 4. Another thread will print 1, 3. So your output should be 0, 1, 2, 3, 4, 5, 6, 11, odd thread, 12, even thread, 13, odd thread, 14, even thread. So here we will learn the concept of synchronize, wait, notify, and notify all. And trust me, after going through the solution, you will have the proper understanding how this synchronize, wait, notify all will work, and without any second round. So let's jump into the solution. So we'll go through the class structure first. So this is an odd even print class. This is the common object. This is the shared object. So see, this object is shared with the both even thread and the odd thread. Okay, odd even print is with the both even thread and the odd thread. Okay, so we have created two threads. How? With the functional interface run. What is a functional interface? And we have assigned it to a lambda expression. And then again we have assigned it to a lambda expression. So the run, this is basically a run method, and we have called it into the thread and even thread and odd thread respectively, and we have started to thread. Uh, let's see first the structure of this odd even print class. So it has one number and one max number. Okay. Then we are setting this max number by the constructor. Then this is the method print even, and this is the method which will print odd. Now, our task is we have to make this synchronize in such a way that one will print even and one will print odd. So now they are not synchronized. I will make it synchronized in such a way that one thread will print even and one will print odd, and output will be 0, 1, 2, 3, 4, 5, 6. So first let's run this till 100, I will say, and we'll see how the output is coming when we have not synchronized them. Okay. I have set their names, even thread name and old thread name. So these names I will be printing here, and we will get like, okay, which number is printed by which thread. Let me run it. Okay. So see, um, see here 85 is printed odd thread, and then suddenly 88 is printed even thread. So see, then 87 printed first, and then 85 printed. So it's coming very discontinuous, right? Even thread, then again even thread come 87, then suddenly odd thread came 85. So we have to remove this and we have to make it synchronized. So what we can do? You will have to be patient here, guys. This video will be little lengthy. So how we can make this synchronized in such a way that one thread will print the odd and one thread print the even and in a synchronized fashion, like in the continuous fashion. 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. It should not be like odd thread, even thread, random, or even thread, odd thread, even threads, not like that. So let's see that. So first basic thing what I will do is I will move this into a synchronized. What I am doing is just I am incrementing the number. I will move this whole into a synchronized. We are just incrementing the number till it's not reaching to the max number. So I will just move this into a synchronized block. Now block on the object level, not on the class. This means it's referring to the object level now. So let me wrap other one as well with the synchronized block. Uh, so we quickly wrap it with the synchronized block. Yeah. So both are with the synchronized block. The main thing is synchronized is here the object level block. This. So the working principle will be uh, for the particular object. Here the object will be odd even print. This lock will be occupied. Uh, we will better understand it with the quiz. Okay. Uh, there are two methods method A to understand the class level synchronized object level with this keyword. And we are printing this. You will able to understand the number from 1 to 0 to 100. There is another method we have synchronized it, and we are printing number from 0 to 100. So these are the two methods, and the MCQ is like which of the following methods will run in parallel and which of the following methods will not run in parallel. So here is the statement. I want I want to know which of the statement is correct and which of the statement is incorrect in this four statement. One, two, three, and four. This four statement, which of the statement is correct and which of the statement is not correct. So let's begin with each statement. Thread R1. R1 is this thread. It is calling method A. Thread R1 is calling method A. Okay. Object A dot method A. Thread R1 and R2 will not run in parallel. Okay. R2, it is also calling method A. Okay. And it's synchronized. Method A, this block is synchronized. So will not run in parallel. So uh, you guys can pause there and then think about the whether the statement is correct or not correct. Uh, okay, let's jump to the solution. So this statement is incorrect. Incorrect. Though appears that this is a synchronized method or this is a synchronized block, right? It will not run in parallel. But the main thing is this is R1 is with the object A, R2 is with the object B. So these are two different objects. That is the main thing. Okay. So this object will here, this will refer to object A, and in the second, this will refer to object B. So those will occupy lock onto two different objects. So R1 and R2 will run in parallel. Okay. Now this next statement is R1 and R3 will not run in parallel. R1 and R3. Object A dot method A and object A dot method B. Let me see that. Yeah. So see, here this is the object level lock. Here this is the class level lock. So these two are two different locks. So they can run in parallel. Okay. So this statement is incorrect because objects are different. So locks are different, right? Locks are different. Now R1 and R5 will run one after another. That is synchronous. R1 and R5. Okay. Yeah. So these are two different threads. R1 is a separate thread, R5 is a separate thread, but the object is same, right? Object is same. So R1 will run R1 will be another thread, R5 will be also another thread. Okay. So yeah, they will not run in parallel. Because why? Because object is same. If we start R1 and R5, though the threads are separate, but since the object is shared, if one occupy the lock, we have to either wait, notify, or notify all to start the other thread. So this is the correct statement. Now, R3 and R4 will run one after another. R3 and R4. This is also the correct statement. Why? Because R3 and R4 are using both method B, and method B is using class level lock. So class level lock will be independent of the object. Okay, so both will have the same lock, and hence both will run one after the other. So this is also correct. And we have to use wait, notify, and notify all method to end the process and start the other thread. So hope now with this quiz it's more clear like how this keyword works, how the object level lock and how the class level locks work. Let's continue our problem statement. Now we have this shared object or this object is common, right? And these are two different things. So if the lock has been taken, if this lock has been taken, other thread will not able to exit. Okay, I hope it's clear till now here. Now let's run and quickly see the output. I would like you guys to pause here and think yourself. So how you should think or how your approach should be like, let's say one object has taken the lock. Otherwise, other object will not able to take the lock. So one object will keep print the complete output. Let's quickly run it and see. Either it could be even or either it could be odd, but one object will take the lock, another object will not able to take the lock because it's a shared object or it's a common object, and it will print from the starting to the end. So let us see it quickly. See, even thread, even thread, even thread, even thread. So even thread took the lock. And this is not the thing which we want. One thread should print the even number and one thread should print the odd number, right? But here all is being printed by the even thread. So what we can do next? We can put some condition here. If number in the let's say I am first printing it into the even, will go in the sequence. If the number modulo 2 is not equals to 0, it's not equals to 0 means it's a odd thread, right? If it's 0, it's a even thread. If it's not equals to 0, it's odd thread, means it's equals to 1. So what I would like to do is I will ask this thread to wait. Okay, let's round it with the try catch. So this I am asking this guy to wait here. Okay. So wait means now the another important thing is wait. It will it will immediately release the lock at this line number 15. And when again this thread will come, it will start from this point itself. It will start from the point line number 15 only execution. This is very important. It will start the execution from the line number 15 only. Okay. And yeah. So similarly, I will put a weight here as well. If the number is even, here I will put the weight here. If the number is even, so is equals to 0, or I can mention it like is not equals to 1. I can ask it to wait, right? If it not equals to 1 means it's equals to 0, 0 means it's even. So I have asked this thread to wait here, right? Now let's see. If I run it, it's not complete because we are not notifying for sure. Okay, so what will happen? We will see first. So it's 0. Let's say thread took the lock. Synchronized. Okay, 0 is less than the maximum number. Yeah. 0 modulo 2 is equals to 0. It will not come here. It will print here 0 even thread. Increment it to 1. 1. 1 modulo 2 is not equals to 0. True. It will go to the wait state. It will go to the wait state. It will come out of the lock. It will release this lock. And then it will start from this particular location only when it will get the lock again. We'll see how it will get the lock, but important thing is it will start from this point on. Now, this thread will get the lock. This thread got the lock. What will happen here? 1. 1 is less than 25. Yes, 1 is less than 25. Um, Now, 1 modulo 2 is not equals to 1. 1 modulo 2 is equals to 1, so it will not go ahead. It will print. It will print the odd thread. One num value 1. It will increment to 2. 2, and then what it will happen? It will come here. 2 modulo 2 is equals to 0. Yes, is 0 is not equals to 1. It will here come and wait state. So now if I run it, both threads will be in the waiting state and it will print 0 and let's see how. See, the execution has not stopped. 0 printed even thread, odd printed odd. Now, how we can make it more correct? Let's see. I have killed the program. Now, what I will do is I will ask, let's now once it is printed odd, I will ask this thread to notify the other that I have done my job. It has printed 1, right? It has printed 1. It has incremented to 2. I will ask the other thread to take the control. I have notified that. And what I will do is I will wait here. 2 modulo 2 is equals to 0 is not equals to 1. I will wait here. But I have also notified the other thread that once I will stop, you can take the control. So it is notified the other thread as well. Take the call. Similarly, here I will put the notify all thing. So here, if it's a one modulo two, first time it will be zero, right? It incremented to one, let's say one. And one modulo two is not equals to zero, right? One modulo two is equals to one. It will go to wait state. But it has meantime also notified the other thread. Let's say other thread is waiting. It has meantime also uh, notified the other to notified all other threads to start the execution once I will leave the control. And then it will start the control from here only. So let's run it and see how. Say 10 even thread, 11 odd thread, 12 even thread, 13 odd thread, 14 even thread, 15 odd thread, 16 even thread. How uh, how continuously they are working, concurrently they are working, odd even, odd even, odd even. So this is all in this content, and friend, I hope you like the video. You got the concept like how wait notify all will work. Notify all will work. Notify all will basically notify all other threads. And the important thing is that the wait will start the execution from the point where it is stopped. This is very important. And yeah, I will come into the next video with the other multi-threading concepts. Hope you like them.